everyone, it's Belle again, and today I have brought up with a TED topic that I have recently did not talk about. Actually, in middle school or elementary school, I usually watched these TED Ed videos, TED education videos. Mostly they're like five minutes, 6 minutes short. So, and they were mostly about interesting scientific facts or interesting history, like stories or episodes within history related to objects or food that we are familiar in the modern days. But since high school, I actually tried to talk more about economics, politics, or law related stories. So I intentionally did not watch any TED videos, but today I did finally because I just wanted to, I thought some little 5 minute shorts of scientific facts would be useful in my life, and the title was very interesting. So the title is Hawking's Black Hole Paradox Explained. And this video was by Fabio Pacucci. So actually it was a little hard for me to explain at first because he was talking a little fast, in my opinion. I'm not a native, so, and also these were all very unfamiliar and unrelative information for me. Well, since I have never learned these kind of scientific facts before. So let me explain for you guys. So a paradox is an uncertain thing, and sometimes it changes the whole scientific research history if something is proved or a certain paradox is suggested. And it might reshape the understanding of the world entirely. And in this case, the black hole paradox, it unraveled two aspects, like two aspects in academy. So first, general relativity and quantum physics. So this black hole information paradox is about, first of all, before I explain the paradoxes itself, let's talk about quantum information. So every single object or physical being in this universe has a quantum information. So let's say that this pen, by the way, is from Hilton, which is a hotel in Chicago. I'm pretty sure it's everywhere in the US, but like this pen, I got it from the hotel because when I went to Chicago to take place in Chicago Empire competition mock trial. Anyway, this was a little TMI from me. Anyway, so this pen has a quantum information, and usually for us, like the most basic primary information of objects are visuals or the touch or sensitivity of it, how flexible it is, the taste, smell of it. Like these are the most basic information that we could observe from our human body. But quantum information is different. Quantum information of an object is position, velocity, and spin. So there is something called and also this quantum information, the total amount of quantum information in the universe, it is conserved, it is said. So even though I crash this, I break this, or I make it into dust, ashes, the quantum information still exists. So it doesn't disappear even though I physically disorientate it. Destroy it. So, and in theory, the recreation of this is possible. So recreating it. For example, like if I break it or make it into dust, So in reality, it's really hard and almost impossible to make this as the same original shape. But however, in theory of quantum information, it is possible. Anyway, so what happens if these objects go into the black hole? What will happen? First, there are lots of suggestions or arguments on this topic. It is a very controversial topic in science. So some people say that if an object goes into the black hole, it will disappear. Then does the quantum information disappear as also? Not 100% sure, but there is a possibility that the quantum information in the black hole still exists. And the second argument is that it doesn't, like, when an object goes inside the black hole, it doesn't really literally goes inside it. It just exists at the surface. So the quantum information exists at the surface layer, which is called the event horizon of the black hole. And as the mass and the amount of the quantum information increases together, so as more and more objects are at the surface of it, then the mass of the black hole increases because of the quantum information it contains, it possesses. So at this point, Stephen Hawking, the famous Stephen Hawking, he brought up with a paradox. This is called the Hawking radiation. It is that the evaporating black hole, so the black hole evaporates gradually, and then there is a possibility that these quantum information might disappear entirely. Because the black hole evaporates gradually, it sheds its parts, its particle is shedded beyond, like, gradually far away from the black hole. And however, there are also some arguments or research that even though the black hole evaporates or sheds its particles, still, like, it could be still encoded in its escaping radiation. So it still stays in that escaping radiation even though it evaporates. So if this is a black hole and particle is shedded, some people might think that this goes just far beyond that information just disappears, but it's not. Like, it still has that radiation that could encode the information. And also there is another principle based on the Hawking radiation. It's called the holographic principle, which means this was actually the most interesting and unbelievable one. This is that the boundary of the entire observable universe is 2D, like it's two-dimensional, like an animation. However, the contained, like the involvement, like, however, the objects, the earth, human beings, these kind of physical objects are all encoded with 3D, with 3D. So this kind of means that everything we see in our daily lives, reality, is a holographic projection. So actually, like, this video was not an explanation of how this paradox was solved. It was more like an explanation on a diverse, various principles, researches, or arguments regarding the black hole paradox of Stephen Hawking, and also an explanation of the quantum information within this universe. So actually, this was a very entertaining video, and it also kind of motivated me to research more about this black hole paradox thing. So maybe if I have some free time and if I have the flexibility of time to do so, I will definitely research black hole paradox with more detail and more deeper. Yeah, I think time is up. It's almost 10 minutes. This will be my TED Talk for today. Bye.